Hello, everyone. Welcome to this video. We're talking about functional functions. So this is part of the series of further differentiation. So we already have two videos on the standard derivatives. Is that okay? So we're going to talk about functional functions. So before we go on, we'll just look at this. So we'll say, what is a function of functions? Okay. So let's say we have something like cos x, for instance. So you can say, cos x is a function of x. So because you just need to have x, that will determine what the value of cos x will be. But when you have something like cos 2x, or let's say 3x plus 5, okay? So that means there are two functions here. So the first thing is that the cosine is a function of 3x plus 5, okay? So it's a function of 3x plus 5. And the 3x plus 5 is a function of x. So that means a function of a function. So that means you have to get 3x plus 5, you need to find x. And when you get 3x plus 5, then you can now find a cosine, all right? Now, in order to do this, there are three things to talk about. There are three rules we usually use here. We have the first one called the chain rule, okay? So there are three rules for the functions of function, okay? There are three rules. The chain rule. The other one is called the product rule. And the last one is called the quotient rule. Okay, so there are three rules we talk about here. Now, in this video, I'm going to only talk about the chain rule, and the subsequent video will be the product rule, then the quotient rule. Okay, all right. So I'm going to start with the chain rule. Let me go to a new slide. Okay. So the chain rule, all right? So you use it for the functional function. So let's go back to that example. Let's say we have y is equal to 3x plus 5, okay? We have y is equal to, let's say sine, to make it easy, sine 3x plus 5, okay? So from the word chain means that they're both linked together, all right? So we're told to find the y dx for this. So that means we're told to differentiate this, and you want to use the chain rule here. Now, this is a function of function because you can see sine is a function of 3x plus 5, and 3x plus 5 is a function of x. So definitely it's a function of function, all right? So in this case here, what do? We'll make it very simple. So what I usually explain to students is that I always say let u to be equal to 3x plus 5, okay? When you say u equals to 3x plus 5, then I can now find my y. So I can now say y is going to be sine u. Can you see? So I have two different things here. Okay, we have y is 3x plus 5 and y, because if this is u, that means y is going to be sine u. Easy. All right. Now, let's differentiate this. So du over dx, okay, because differentiating u in respect to x is going to be du over dx, and that will give you what? 3. So if you go to my previous videos, we talked about the derivatives. So remember we said sine, cosine, minus sine, minus cosine. So that means when you differentiate sine, it's going to give you what? Cosine. So that means if you differentiate y in respect to what? U. It's going to give you cos what? U. But we know that u is 3x plus 5. So we can say this is the same thing as saying cos into bracket 3x plus 5. So that means I can now say, therefore, my du over dx is equal to 3. And I can also say that the y over du is equal to cos 3x plus 5. But the question is not asking me to find the u over dx, or it's not asking me to find the y over du. It's asking me to find the y over dx. So what do? Now we're looking for the y over dx, but if you look at it closely, if I multiply du over dx by dy over du, it should give me the y over dx. How? Look at it. You have du over dx multiplied by dy over du. Can you see? I mean, this cancels this, and you have the y over dx. So what I have to do, I have to multiply my dy over du, which is 3, by, du over dx, which is 3, multiplied by my dy over du, which is cos 3x plus 5. And then it will now give me the y over dx which is equal to 3 cos 3x plus 5. And that is the answer for that. So that will give you cos 3x plus 5. Let me see if I can squeeze another question in like a minute. Because remember, we do it in 10 minutes, okay? So we have, let's say we have another one. Same principle, y is equal to 4x minus 5 raised to the power 6. Okay, it's a function of function. So that means the 4x minus 5 depend on x, and the function depends on 4x minus 5. That is, the function raised to the power 6 depends on 4x minus 5, and 4x minus 5 depend on x. So that means a function of a function. The same principle, I'm going to say let u to be equal to 4x minus 5. So therefore, y is going to be u raised to the power what? 6. Easy. All right. Then we differentiate this. So du over dx is going to give you what? 4. And dy over du is going to give you what? 6u raised to the power what? 5. All right. So, but we know our u is the same thing as what? 4x minus 5. So that means this is 6 4x minus 5 raised to the power what? 5. So like I said, we're looking for the y over dx, okay? This is what we're looking for. And we know that the y over dx is going to be du over dx multiplied by what? The y over what? Du. U here cancels here. So that means you have dy over dx. So that means we need to multiply our du over dx, which is going to give you 4, multiplied by our dy over du, which is 6 4x minus 5 raised to the power what? 5. And this is going to give you 24 4x minus 5 raised to the power 5. Okay? And that is how you get the answer for that. So let's take it maybe a little bit step. Maybe let's add a logarithm, okay, to this and solve it as well. So we have, let's say y is equal to ln. Ln is a natural logarithm of 3 minus 4 cos x, okay? So that means this is a function of a function here. So you're going to say let u to be equal to 3 minus 4 cos x. So therefore, we have y will be equal to what? Ln u. Okay? So we have du over dx will now give you sorry. So du over dx is going to give you, you differentiate this, and that will give you, bring out the minus 4, okay? If you differentiate 3, it's going to be 0, okay? So cosine, so remember I said sine, cos minus sine minus cos. So if you differentiate cos, it's going to give you minus sine, and that will give you minus sine what? X, okay? Now, but if you differentiate ln u is going to give you the y over du, going to be ln, going to be 1 over what? U. And we know our u is 1 over 3 minus 4 cos what? X. Thing. So that is that. But we can also simplify this one here. The value we have here, minus 4 minus sine x, and that will give me 4 sine x. So that means du over dx is equal to what? 4 sine x, and the y over du is 1 over 3 minus 4 cos x. So, but we're looking for the y over what? Dx, which will be equal to du over dx multiplied by the y over what? Du. Okay? So therefore, we can now say the y over du is going to be 4 sine x multiplied by 1 divided by 3 minus 4 cos what? X. Then that will give you 4 sine x divided by 3 minus 4 cos what? X. Thank you. And that is how you differentiate using the chain rule. All right, so let's quickly revise what I said. I told you that the chain is where you have a function of function, and you have cos x equal to x, and it's a function of x. But when you have something like 3x plus 5, that means 3x plus 5 depends on x, and cosine depends on 3x plus 5. So it's a function of function. And we have two types. We have the chain rule, the product rule, and the quotient rule. And here I focus only on the chain rule, and I gave you, so that means you have to break it down. So you take one of the functions out, okay? So u is equal to 3x plus 5. You differentiate it, you get an answer. Then y will be equal to the sign of the second function, okay, which is sine u. Differentiate it, you get an answer. You multiply both of them, and to give you what? The y equal dx. Okay, thank you very much. Thank you for this time. The next video will be talking about product rule. Okay, so don't forget to like, comment, and subscribe. I also turn on the notification button so you can be aware of when I post a new video. Thank you very much.